sorry I'm not there today. In this video, I'm going to go through the first part of the worksheet that I've given you. We're essentially going to learn some content as we go through and apply it to the questions. So rather than normal board notes, we'll just learn as we go and apply it to some questions. Hopefully I'll be back tomorrow and we can go over anything that we weren't too sure about. So for those of you that were there on Friday, you would have learned about transition matrices. So for the 7 or so of you that were away, we'll do a bit of a brief chat about that in this video. But what might be a good idea is take a photo or copy out the notes from someone else that you're sitting next to. And as I said, I can go through it with you again tomorrow, and we've got plenty of time prior to exams and assessments and all that. So I'll be able to take you through it. But for this one, what I'm going to do is I'm going to go through the first category here, in this case beef. There's 3. I'm going to go through the first one in this video, and then you can have a go at the next couple yourself. The solutions will be on Compass. You can check through as you go through. So this is a practical example of transition matrices. In this case, we have got different meats, vegan-friendly meats, and their market share in comparison to each other. So have a bit of a read through of the information here. You can pause it at any time if I'm going too fast. So here we have 4 different products. We got the V2 burger, the Love Buds, Beef, and Beyond Meat. For the purpose of these questions within the matrices, they're going to be defined by the letters up here. So V2 will be defined by A, Love Buds B, Beef will be represented by C, and Beyond Meat will be represented by D. So in last week, we only really did some 2x2 transition matrices. We're stepping up a little bit in this one. We've got a 4x4, but it really just is still the same. All the columns add to 1, so that's a really, really important feature of transition matrices. They must add to 1. Just looking at some of the numbers in here, I'll just zoom in. Oops. So this 0.76 in context means that 76% of people that buy A, which was, what was A? That was V2, will buy A V2 again next week. This 0.12 here means that 12% of people that buy A will buy C next week. This 0.04 means 4% of people that buy B one week will buy C the next week, and so on. 0.93 means that 93% of people that buy C will buy C again. So that's the transition matrix for all 4 products there. Now, something that we haven't talked about yet is what's called an initial state matrix. So transition matrices have 2 key things. What's called the transition matrix, which is typically denoted by the letter T. Let's write that here. And what's called an initial state matrix. So initial state matrix will look like this. So S0. So that's a little 0 there. S for state, 0 is because it's initial, it's the starting value. So if you remember back to the SAC that we did earlier in the year that collectively as the cohort we didn't do too well on, where we had S0 and V0 and T0 for all the initial terms and that. It's kind of like that. This just means that it's the initial starting information. Now, these initial state matrices are always column matrices. And essentially, they give us the beginning information. For this one, it's the information here in the table. So if I set this out, I might just write it over here so I've got a bit more space. In this case, I've got a 4x1 matrix. If there was only, say, 2 different products here, it'd be a 2x1. If there was 3, it would be 3. But because there's 4, there's a 4x1 matrix in this case. Excuse me. Now, in these matrices, sometimes you've got percentages like up here, or you've got actual numbers. So theoretically, the question could be like, all right, 500 people bought the V2 burger, 180 bought the Buds burger, or whatever. They can be numbers or percentages, and it doesn't really change the way we use them in our calculations. Now, A, initially, 34% of people were buying. So when I put that into my matrix, I'll do this, right, 0.34. So like with the transition matrix, if we've got percentages, we'll put it in as a decimal. Product B had 2% of the market. So I'm going to put that as 0.02. Product C had 9% of the market, so 0.09. And D was the most popular, has 55% of the market share. So initially, the popularity went with D, A, C, with B being the least popular. So that's an initial state matrix, the beginning information. Say, with the example that we did on Friday with the Ferris wheel and the merry-go-round, say 200 kids rode the Ferris wheel first and 180 rode the merry-go-round first. It would just be those numbers in there, 200 and 180. As I said, please pause this video if you need to. All right, determine the market share for each of the products after 1 week. Show your input into the calculator. All right, so I'm going to give you a bit of a formula here. This is where a transition matrix comes in handy because it literally shows us the transition between time. In this case, we'll do 1 week, and then after that, we'll do 10 weeks. So as a bit of a general formula, we can use this. And I'll explain it as I go through. All right, so T is our transition matrix. SO, as we just went through, is the initial state. And up here, we've got N. That just means the number of transitions that we want to find. Or like kind of the amount of time that's passing. Depends on the context of the question. It could be weeks, months, years, days, but it will specify. So if I want the market share after 1 week, quite straightforward. I would just go transition matrix to the power of 1 multiplied by the initial state matrix. Now, I'm probably not going to have enough space in here to write that out, but if we jump over to the CAS, we can do that. We can save the matrices in and go from there. So I'm going to save my transition matrix first. So I have my sheet in front of me. Oops. All right, so there's my transition matrix. I'm going to save that as the variable T. Enter. I'm going to do the same for my initial state. So that'll be a 4 by 1. Save that as just S. So if I want, say, one transition, in this case after 1 week, in this context, it would tell me what percentage of people bought each of these products. So I go T. I mean, the power of 1 is kind of redundant in this case because power of 1 doesn't show anything, but we'll put it in just to practice. And there's my answer. So basically what that means is after 1 week, when rounded, that would be 32% of people still buy product A, 8% buy product B, 21% product C, and 39% product D. And it's really easy once you've done that. If I wanted to find out after 2 weeks, I just raise it to the power of 2. And that's how many people, or what percentage of people, I should say, are buying after 2 weeks. So jumping back over to the worksheet. I'll try and squeeze my answer in here. After 1 week, excuse me. With this next question here, it says determine the market share after 10 weeks. Well, same thing. I'll just go T to the power of 10 multiplied by the initial. And there it is. So after 10 weeks, that's what percentage of people are buying each product. And usually with these ones, we just go to 2 decimals because we're dealing with percentages. So in this context, after 10 weeks, 16% of people are buying product A, 24% are buying product B, 51% product C, and 9% product D. So there's been a bit of a shift in which ones are the most popular. Part D says after 10 weeks, who had the biggest increase in their percentage of market share? So what we can do with that one is we can just close those. Go back to the original and see what the changes are that have occurred. So if I go back to my original, I can see that product A originally had 34% and it's gone down to 16, so it's actually decreased. Product B, I'll write my answers here. So product A, product B, product C, and product D. So A went from, what was it, 34% down to 16. So that's like a negative 18% kind of swing. B went from 2% to 24%. So it's increased by 22%. Product C looks pretty popular now. Was 9%, now 51%. So it's gone up by 42%. And product D was 55 and is now 9%. So that one's actually gone down by quite a lot. So product C saw the greatest increase in their percentage of market share. Last thing that I'm going to go through with you, then I'm going to shut up. In the long term, which product has the biggest market share? All right, so long term, which refers to something which is called the steady state matrix. What happens with transition matrices and the initial state matrix is it gets to a certain point where it doesn't change anymore. So it just reaches a point where the states don't change. So if I work out 50 weeks or 100 weeks or 200 weeks, it'll get to a point where it just doesn't change and it's stuck like that. So the steady state, we'll give it a bit of a definition, is a point where the transitions don't change. Now, to calculate the steady state, it's pretty straightforward to work out. What you do is you just raise it to that transition matrix to a really high power, and then we do the number after that, and if there's no change, we know that the steady state has been reached. So I'll show you that in a moment on the calculator. All right, so I'm going to jump back over to the CAS. Pause or rewind the video if you need to. I usually just say do 100. That's usually a safe number. So I go T to the power of 100 multiplied by the initial state. And we can see there's our answer. Now, if I do the exact same calculation, but I change it to 101, what I can see is that the two answers are the exact same. There has been no change occurring whatsoever. What that tells me is I have reached what's called the steady state, which sometimes the questions will say in the long term. They mean the same thing. So I've reached the steady state. There's my answer there. So the question said, which product had the greatest market share in the long term? Well, looking at this, it would be product C, 0.53 or 53% of the market share. The question says, how can you be certain that the steady state has been reached? I'll let you answer that in your own words, but basically there has been no change between the transitions. We raised it to a high power and nothing changed. All right, so I'm going to stop it there. Have a go at the next ones on the next few pages. If you're not up to date, you can prioritize your other exercises. Progress reports are coming out this week, so try and get up to date. Hopefully I'll be back tomorrow, and we can go through some of this again if any of it didn't make any sense. Answers to these will be on Compass, so you can check it as you go through. Thanks, guys.